Let's say you have an existing AWS EBS volume, and you are required to encrypt it. You cannot simply flip a switch or directly apply encryption to a drive that is already running in your environment. Instead, we have to create a snapshot of the current drive and use that snapshot as the foundation to build an entirely new encrypted volume. But before replacing active infrastructure, we must account for two strict business limits: the amount of downtime the business can tolerate and the amount of data it can afford to lose. This timeline outlines the recovery time objective, or RTO, your strict downtime limit. If RTO is 2 hours, systems must recover within that window. Adding a secondary axis tracks recovery point objective, or RPO. An RPO of 1 hour means hourly backups, limiting data loss. Meeting those precise RTO and RPO limits while fixing legacy encryption vulnerabilities requires mastering one specific process, the EBS Snapshot lifecycle. Looking at this architectural diagram, we start with an active EC2 instance connected to a volume labeled unencrypted EBS. To prove our transition process protects the data, we first need to build a verifiable baseline state on this instance before initiating any backups. Access the terminal. First, install the HTTPD package and configure it to deliver a test web page. Next, run the command line installations for 2 additional functional packages, tree and telnet. Finally, add an entirely new system user to the environment and assign a unique password. Whenever you execute modifications like this on an instance, you must run a sanity check, sometimes called a smoke test, immediately afterward. To perform this sanity check, restart the EC2 instance. Once it boots, verify that the test web page loads properly and that you can log in using the new user credentials. By establishing these functional elements, we have created an undeniable data baseline. We will use these elements later to verify that 0 data drops during the volume swap. Now, move to the AWS console interface to begin the data capture phase. In the EBS Volumes pane, locate your target unencrypted volume. Select the volume, open the Actions menu, and trigger the Create Snapshot command. An EBS snapshot is a strict point-in-time copy of the drive, capturing the precise state of the data exactly when the command registers. Behind the scenes, AWS relies on its backend storage for this operation. The actual physical destination for your snapshot data is an S3 bucket. Because the storage utilizes S3, users often ask, can we look inside that bucket and view the individual files? This flowchart illustrates why the answer is no. Data moves from the EBS snapshot into an S3 node, but that destination bucket is entirely opaque. Your snapshot files remain hidden and will never appear in your standard S3 bucket inventory. Even though the storage backend restricts visibility, the point-in-time copy is fully secured and ready for the encryption phase. With the snapshot complete, shift over to the AWS Snapshots dashboard to initiate the volume recreation. Select the Finish Snapshot and execute the Create Volume from Snapshot command. During this creation window, locate the configuration setting marked Enable Encryption and check the box. If this is missed, the new volume will remain unencrypted. Let the new volume finish generating, then return to the primary EC2 instance dashboard to begin the physical swap. First, select the old unencrypted volume and issue the detach command to sever its connection from the EC2 instance. Immediately, target the newly generated encrypted volume and attach it directly to that exact same instance. Because the data duplication occurred quietly during the snapshot phase, the actual detach and attach sequence takes only moments. This minimizes the offline duration and keeps the operation strictly within the organization's RTO limit. Bring the EC2 instance back online to confirm the success of the swap. Refresh the browser to ensure the test web page delivers properly, and attempt an SSH login using the baseline user credentials. Once logged in, execute commands verifying that both the tree and telnet packages operate smoothly. Looking closely at the volume details pane, the old drive registered as unencrypted, but the new active volume displays a green encrypted status. The baseline test proves absolute 0 data was lost during the transition. We have successfully executed a manual encryption swap. Now we future-proof the infrastructure using the Data Lifecycle Manager, or DLM. DLM automatically handles the lifespan of future backups. It schedules creation of new snapshots, manages their retention, executes backup copies, and handles deletions when backups expire. To target resources, DLM relies entirely on associated tags. You configure the filter by applying specific tags at either the broader instance level or directly on individual volumes. By combining a one-time snapshot injection to encrypt legacy drives with automated DLM tagging moving forward, your AWS infrastructure stays secure, compliant, and always protected within your RPO boundaries.